This presentation demonstrates a Navigator for Unix, a graphical interactive interface to the Unix programming environment. The demonstration will show both the Navigator application and the framework within which it was built. Navigator was developed during 1988 at ParcPlace Systems Incorporated. The concept of navigation is based on three ideas: path traversal, visual feedback, and system aids for the user's memory. Navigators operate on information that is modeled as hierarchies of paths, places, and contents. Information can be viewed in structured or unstructured groups, such as trees, outlines, or lists. Browsing within a hierarchical structure is carried out by direct interaction with its graphical representation. Constant visual feedback of selection and system state is provided. In the directory view, we can navigate among the directories of the Unix file system, opening and closing levels of the hierarchy. Paths that were recently opened are remembered by the system and can be quickly reopened. We can present the directory hierarchy, which is a directed acyclic graph, as a tree or an outline form. Leaves of the directory tree are files, which can be browsed in the Files view in various presentation styles. In addition to opening and pruning trees, direct manipulation is used for configuring the structure by moving items among nodes. Dragging single or multiple items in directory space is equivalent to moving directories or files. The directory tree can grow quite large, and the views can be scrolled using several interaction paradigms, including scroll bars or grab scrolling. Leaves of Navigator structures can be selected to open them. Accessing the contents of files within the Navigator is one way of opening them. As is implied by the file view's icons, the Navigator recognizes a number of Unix file types and provides for viewing and editing files based on their type. Opening a raster image file, for example, lets us browse its contents in the rightmost view. Opening a text file allows the user to edit the file's contents using the built-in text editor or other editor, such as VI or Emacs. Selecting an executable file, such as this shell script, creates an interaction dialog box. Up to now, we've interpreted the opening of a file to mean accessing its contents. File properties are simply another view of files. These property sheets show us several items related to a file, such as its owner and owner's group, its Unix protection and type, and its creation and modification dates. This property sheet is interactive. It can be used, for example, to change the protection of a file by editing the boxes which display the protection. Easy access to the Unix shell is also provided in that the selected file view can be turned into a shell terminal. The Navigator window has up to 5 subviews which can be sized and collapsed to manage the display. The subviews can be rearranged by dragging any of their borders around, possibly collapsing the view down to a small, visible tab. We call this type of view a Swiss Army knife view. 3 subviews are now visible within this window: the directories, files, and selected file subviews. Simple search aids are provided using filters and queries for locating files. File name filters, for example, can be specified to view the file list based on name pattern matching. Path queries can also be used for finding directories or files within hierarchies. The Navigator remembers recent selections and can be used to revisit places or to reselect objects. If necessary, intermediate paths will be opened to navigate to a place selected with this feature. The Navigator window has several interesting components in its top and bottom strips. We call these strips the label and message regions. The View and Act buttons along the top are used for manipulating the window itself. All 4 corners of the window are resize tabs. The message view at the bottom is used for informing the user of selections or of exceptional conditions. The small logo in the lower right corner is the About button. When pressed, it displays the version and copyright information of the Navigator. In summary, the central operational features of the Navigator are its support for switching between different presentations of structure and contents, its search aids for finding things, and its ability to quickly retrace recently traveled paths. Now, let's move on to a more structural view of the Navigator application. We have looked at a directory and file space which displayed the structure and contents of the actual Unix file system. This Navigator's second space is called capability space, or task space. This is a tree whose leaves are operations, or dialog forms. The space's hierarchy can reflect the logical structure of the user's tasks. Places here are called capabilities, and their contents are called operations. Navigation and interaction in this space is similar to the directory and file space, with the important difference of what it means to open the leaves, as we'll show you next. As is evident from the highest level nodes of the capability tree, this space is about using Unix for everyday applications and system administration. Operations are things like reading the system's online documentation, accessing system information or applications, or customizing the Navigator itself. As we saw in the case of file property sheets, items we present in dialog forms can be dynamically computed, like the protection bits, or can be accessed by parsing formatted data from files, like the name of a file's owner. This ability is used in constructing dialog forms that carry out complex multi-step operations, such as adding new users or maintaining mail alias lists. The Navigator is implemented in the Smalltalk 80 programming system, although the user never sees the Smalltalk development environment or its tools. The look and feel of the application was also designed specifically for it, and is implemented by refining components of the standard Smalltalk 80 user interface. There are three underlying concepts in the Navigator user interface philosophy. First, interaction with structures is independent of their presentation. Secondly, interaction is split into the processes of viewing control, select open operations, and actions taken upon selected items. And thirdly, the system's interaction paradigms may be tailored by the user. The user interface contains a large range of choices for both presentation and interaction techniques. For example, the novice Navigator system assigns equal meaning to all mouse buttons. It provides access to application functions via mouse-sensitive regions, such as buttons, pull-down menus, and scroll bars. A more expert version allows Shift and Control key chording for extended mouse functions. The system's usual pull-down menus may be replaced by pop-ups, and there are also user-settable function key mappings. In parallel with the development of the Unix Navigator, we built several other Navigator applications to test the flexibility and reusability of the underlying framework. The list of applications demonstrated to date includes Navigator-based Smalltalk 80 software development tools for other programming languages, dynamic book document navigators, and project or room navigators. One of the first tools we implemented and used within the Navigator framework was a new version of the Smalltalk 80 source code browser. Two tree-based editors are used here, one for the system's class categories, and below it, one for the class forest within a particular category. The right-hand pane can either hold a class browser, or it can be used as a manual writer to automatically generate reference manuals while browsing the Smalltalk 80 system classes. An interactive dynamic book navigator has also been implemented for the delivery of Smalltalk 80 courseware. In a tutorial situation, the user moves around the outline of the course book and its exercises. The leaves of this tree are text pages, where students read and execute example code. The development of the Navigator framework and applications was only possible because of the object-oriented methodology of rapid prototyping and incremental redesign supported in the Smalltalk 80 programming system. Navigator is currently being re-implemented for delivery as part of an even more powerful second-generation framework and high-level application toolkit.